We'll continue our multi-cloud networking journey in the second video by focusing on the layer 7 networking using F5 distributed cloud. We'll be deploying a refer a friend widget in our cloud B, which is going to be Azure. And we will connect it to the core application, Arcadia app, which is deployed in Amazon with the same IP address as our friends module, so that we can create this IP overlap scenario. Easily resolved if we use F5 distributed cloud HTTP load balancer layer 7. This is going to be the application that we will be updating at the end of this module. This coming soon space will be replaced with our refer a friend widget. All right, let's get started. In this module, we'll be using Azure as our cloud B. We already have access to a subscription where we'll be creating the resources to deploy refer a friend module. We will also need to use Terraform. We previously used it in the video number 1. In this case, let's make sure we open the right Terraform scripts for Azure. And the last thing we'll need is Azure Command Line Interface, CLI, which we also have installed, in my case, on a Mac. So let's go into the terminal and start issuing some Azure commands. We'll first log in, and this will pop up a browser in a second. Make sure you authenticate with Azure, and then proceed into the Azure CLI session to retrieve the subscriptions, one of which we will use for this demo. Now, in my experience, when I used Azure trial account, I was not able to easily deploy all of the resources that needed to be deployed. There are a couple of VMs that will be required. So as it turns out, it was easier to use a pay-as-you-go subscription, and we recommend doing the same. First step is to export the subscription ID. This will be used as a reference subsequently, and we'll set the Azure account to use that particular subscription. Now, in the first module, we used AWS, and therefore we created a service account and deployed resources there. For Azure, we will use a service role in order to be able to create resources using the CLI. So also make sure that your subscription allows you to create this type of service role. During the deployment, F5 distributed cloud will need to create a VM, which is used as a service VM from which additional VMs will be created. These will comprise the app stack required on our edge, in our customer edge environment, to connect back to the F5 distributed cloud. To do a couple of things, we will need to use Azure CLI shell, which is upload the custom role JSON where we specify the subscription ID earlier. This JSON will contain the definitions for this custom service role and needs to be uploaded into our account. We can take a look to make sure that the information such as the subscription ID, as well as a set of permissions or actions that are defined for this service principal that we'll create based on the custom role as defined in the JSON file. Now let's create the role definition, which references the JSON that we've uploaded, and we'll do it inside the Azure console. Make sure you're not doing it on your local machine. But then, after that command is issued, the rest of the commands we can do on our local machine. This one is going to create the service principal and the assignment of the custom role created. Make sure you pick the right cloud, so Cloud B, Azure in our case. Now, the next command will be the one to create the service principal role, and it will refer the name here, F5XC Azure role, which is what we've defined earlier. Give it a name, F5XC Azure SP, which is service principal, and reference the subscription ID, which was exported as a variable previously. The output of this command is important. Keep it, don't lose it. It will have the app ID, password, and attendant information, and the display name for the service role that we just created. So I'm going to copy that into a handy file. This is where I will be copying and pasting values from into the Terraform script in the subsequent set of screens. So first of all, it's very simple to follow. Just first copy the subscription information. You can pull it by echoing the exported variable, but this is also easy since we just set it earlier. The tenant ID, which was returned by the service principal command earlier. We will also set the password and the app ID inside our Terraform scripts as well. Now, the good news is that we can reuse the service principal for subsequent modules In this case, we'll be doing module 3 in Azure as well in a different VNet. So this is going to save us a little bit of time. Just like we did in the first module with the AWS site, we will need to use the tenant information for our distributed cloud F5 distributed cloud tenant TME LabWorks, and also a certificate, which again we need to generate by going under administration, credentials, under personal management, and there we will go and create a new API certificate. This API certificate, together with our tenant info, will be used by the Terraform scripts to create all the necessary resources for our second module. This certificate will be downloaded in your browser, and next you have to copy it into the working directory for the Terraform scripts. So in our case, it's Cloud B Azure, so make sure your certificate is copied there because we will reference it from the Terraform scripts. Let's go ahead and do this now. We already can see that the certificate has been updated, so let's copy the name and we'll populate that information first. So we'll go under the variable API IP12, punch in the certificate information, and now that we have it, we can go and do the rest of the configuration, such as exporting the password used by the certificate, which was set up in the X5 distributed cloud. And now we can just run the Terraform script. So I am rerunning the Terraform init script in this case. You don't have to do it. You can do it only once for all the modules, but just to make sure that it's rerun in a sequence, we did it. And next, Terraform apply to apply the Terraform scripts as configured with all of the variables that we defined. At the end of this Terraform deployment, we will have a fully configured refer a friend module that resides in Azure and a site that would be created in the F5 distributed cloud. Now I sped up the Terraform deployment scripts, of course, as well as shortened the time that it takes for us to see the Cloud B deployed. You can see it's now showing online. And this is just to save time in our demo. This might take a few minutes, so grab a coffee and make sure that you are ready to do the next step. Once the cloud is created, our site is created. Now we need to connect the two sites together. So the previous site A with the site B. We'll use HTTP load balancer, and therefore we're going to go ahead and add a new one from scratch. Follow the instructions to create a refer a friend module load balancer. Give it a name, and for the domain, it's again from the DNS tool that we used in the first part of our demo, where you get the Arcadia DNS zone name. So in our case, this is Verbal Indigo. We're going to take that and we'll append refer a friend specific subdomain friends dot. So friends dot verbal indigo, etc. Make sure you do the same with yours. Now here, it's important to select HTTP as the load balancer type. We're not using HTTPS. HTTPS is going to be HTTP straightforward port 80 connection. Next, we need to configure the origin pools, which is a collection of endpoints grouped together into one resource pool to be used for the load balancing of our application. In this case, the add a friend plugin. Because we don't have one configured, we'll create a new one, provide a name for it, and then go through and select the port 80 for the origin server, which is where the application is running on. So the application deployed in Azure is running on port 80. When we get to the origin server type, we will use the IP address. And as mentioned at the beginning of this video, it's going to be the same exact IP address as the service that we have running on Amazon. So typically you would say this is now causing IP conflict. However, because we are selecting HTTP load balancer, that should not be an issue. We'll select Cloud B, the site that we just created, and pretty much at this point we're done. We're going to accept all of the values that we have here, all of the default settings for TLS must be disabled, by the way, because we're using port 80. And here we're done. We have the friends origin pool defined. Apply. We'll keep all of the other options as default, but we could have configured the web application firewall or bot defense protection or DDoS protection even. One important thing is now we will advertise this VIP, this endpoint to the old side, which is the core application that we configured in the module number 1. You have to select the inside network here, and from the list of the site references, select the Cloud A reference, which is the deployment that we have had earlier. So now our friends module will be advertised to the core application and will be visible by the core application. So we are almost completely done. All we have to do now is to extract the value of the private IP address from the deployment in order for us to be able to update the DNS settings. And we'll need to be in the directory where we ran our original script. So we're going to be backing out back to the Cloud A deployment in AWS in order to retrieve the IP of the node where we have our application running, our core application running. So this is the Terraform output is providing us with that detail. We're going to grab the IP address and pop it back into the DNS tool that we used earlier. This is the last piece of information we'll need to fill out on this DNS tool. After that, we don't use it anymore. So now in a few minutes, the DNS will be updated and we'll be able to see on our website, on our core site, the new module being active. The new Refer a Friend module should be active. So let's hit refresh, and there, after some time, we'll see it live. Great. So we have completed our process of setting up another cloud, connecting it via HTTP load balancer to the core application, setting up the origin pool, and the advertising of the VIP to the original application using HTTP layer 7. In the next video, we will complete this guide in the module 3 by creating a new service in the Cloud C, which is going to be Azure in our case, and connected back to the core application with layer 3 networking.